Start. Is it recording? Yes. Okay, so before starting, I will repeat this how to say, this recommendation this morning at the beginning, at the break, at the end, and so on. You know that they called JCT, Joint Committee for Teaching questionnaire, is open. Its name is CPD in Italian, Comitato Politecnico per la Didattica. So you can leave a feedback for the course, okay? Your colleagues did this last year for you, so please do the same for your colleagues for next year. And this is especially useful in the part where you can write open feedback. Of course, it's anonymous. You can write whatever you want. And typically we take into account your considerations for preparing the course for next year. So last year, we got some feedback and we modified a few things in the course as well. Okay, so this should be a course where this is useful. We know that for some courses, teachers don't care that much. We care a lot. Okay, so please leave some feedback if possible. Okay, the schedule, you already know the schedule for the course, and the schedule is here. We are here today. We're going basically to discuss the last topic for the course. Next week there will be no activity, and the week after there will be 2 labs, okay? And then the text of the first exam will be published, and there will be a last lecture on the last day for the course, that is June the 4th, okay? Okay, so and we will see an example for how to design a solution for an actual exam. Okay, so let's start with the topics, unless there are questions, just feel free to interrupt me. And today we are going to talk about something in addition to password authentication that is required for the exam as well, okay? Because, nowadays many websites are not satisfied when you log in with username and password. Often they ask for an additional form of authentication. And why? We need to understand why and how to design, how to implement these systems, okay? And before that, how it works. So, can you give more than one evidence, more than one kind of type of credential? Yes, we can, and there are systems quite easy to use, I would say, today. So, you know that protecting web applications is difficult. We saw some examples during the course, like cross-site scripting. This click hijacking means somebody sends you a link, you click on this link, you expect to visit some let's say, website of some alleged applications, and instead it's something that looks similar but has been hijacked or modified by some attackers to trick you into do something that you don't really want. Okay? And since there are so many issues, and we saw some mitigation strategies. Be careful for cross-site scripting. Don't use some functions. We could, devise some ways of, we were going to talk about how to stop cross-site request forgeries. That is the name of this kind of things and so on. But in general, it's difficult to protect web applications. So basically nowadays, most of the website that cares about security decides that username and password, so the traditional credentials, are not enough, and they want you to provide, as a user, to provide an additional form of authentication. Okay. This procedure goes under the name of multi-factor authentication. Of course, when there are just 2, as it is usually the case for most of the application, if not all, it is called 2-factor authentication, also abbreviated as 2FA. Okay? Gmail, Meta, even the Didattica web portal, at least for teachers, it requires a 2nd-factor authentication and so on, maybe for students as well. Okay? So it's pretty standard nowadays. And the point is that the user is required to present more than one type of evidence to authenticate on a system. And a factor is something that should belong to a different category, because it's not enough to ask for sort of second password, what is called maybe a PIN or a security question or something else that you know. okay? It should be something different, in a different category. And the categories, as listed on the OWASP website, are basically this one. Something you know, the traditional secret password and so on, secret strings, or something you have, some OTP tokens, certificates, smart cards, email, okay? They send you something by email. I mean, this is not the best option because, you know, email has the same problem. If it's not protected very well, I mean, you're just moving the issue of protection to another place, like email, or SMS, phone calls, and so on. So they are using basically your phone or smartphone to get some other information that constitutes a second form of authentication. Or something you are. They may ask you for fingerprint, facial recognition, scans, and so on. Or somewhere you are. I'm not saying that these all factors have all the same strength, okay? Because something may be modified more easily, okay? Like somewhere you are. I mean, the source IP address, maybe it's better to say, I mean, the geolocation. So you are connected to a certain device that cannot be moved, like an access point and so on, geofencing and stuff like that, okay? Or something you do, behavioral profiling, keystrokes, mouse dynamic, gait analysis, how you walk and so on, okay? So something that is peculiar to you and as a user, and it can be, I mean, recognized with a certain amount of confidence, okay? Quite high confidence. Okay? Otherwise, I mean, if you cannot distinguish users, I mean, it becomes a little bit, less useful, of course. Okay? So, the two-factor authentication we're going to see today belongs to this sort of system of multi-factor authentication with just two factors, and the two factors must belong to different categories, as I told you. It cannot be like a password plus a PIN. A PIN is like another sort of secret string, okay? So, I mean, it's like asking for two passwords. I mean, there's not that much different. And by the way, multi-factor authentication, two-factor authentication is really by far the best defense against the majority of password-related attacks. So people that try to guess the password and these kind of things. When you have a weak password, we saw examples. I mean, we cannot really force users to use really strong password because if they take, I don't know, their birth date, they concatenate it with the pet name and so on. Maybe this information is available on some social network and so on. It looks more or less like a strong password, but maybe it is not, right? So if you ask for a second factor, this is great from the point of view of security because, I mean, the second factor in a second category is designed in a way that, cannot be easily cloned, okay, recreated and so on. This second factor is typically required at login because login is a really important procedure because logging in means you are recognized as a user and so automatically in most of the websites you get permission to do some actions, okay? So authenticating you is very important from the website, from the point of view of the website, okay? It may also be appropriate to require a second factor to authorize other sensitive actions, okay? So most of the times, many websites, in some occasions, they think it's really sensitive, ask again for a second factor. I mean, actually to authenticate the action you're going to perform, not really to authenticate you, to authorize the action that you're going to perform. It's not really to authenticate you because you are already authenticated, but just to make sure that you are the one who requested to perform such action, okay? And you want to authorize such action. So examples are like changing passwords, okay? Changing password is really, you need to pay a lot of attention, or the contact email, because if it's not you, you get, you lose a way to be contacted from the website, from the system, and so on. Or maybe disabling second factor authentication, of course, granting additional privileges, so promoting you to administrator level and stuff like that. Okay? Or maybe performing sensitive operations like money transfer. That's a classical example. Okay, the bank wants you to confirm the action on another device, for instance. That's a typical thing that happens. Permanent deletion, if you go on GitHub, you want to delete a repository, they require a second factor to authorize this operation, which is pretty strong in terms of consequences and so on. Okay, so I mean, we need to learn how to use them. And we will learn how to use them in the simplest case, actually, that is at login time. Okay? Otherwise, we require a much more complex application and much longer discussion and so on, which is not really the purpose of the course, but the purpose of the course is to understand the reason and the technologies involved in how to implement these kind of things. So, we will focus on a very simple second factor authentication mechanism that is based on one-time password. Okay? And there are different ways of achieving this goal. So creating a temporary password to be used together with the traditional password at login time to recognize you in a more secure way. There are hardware-based systems, so one-time password tokens, they call them tokens, even though, I mean, a token in this case is just a device if it's hardware, or just a software running on some devices, okay, in case it's a software one-time password, okay? So, I mean, these were quite widespread until a few years ago. I mean, typically banks distributed this kind of devices that you attach it to keys and these kind of things because you have to have them with you if you want to authorize some operations. And so often this is quite inconvenient because it's hardware you need to carry with you, right? I mean, we already have a sort of hardware that we carry with us all the time, that is the mobile phone. And so, you know, software tokens gained a lot of attention and became much more widespread, okay, because they are so convenient, okay? And you can have different types on the same device for different websites and so on, okay? Hardware tokens have a big plus that they are almost impossible to compromise remotely, okay? Because they have no network connection, they are just synchronized with the server using a precise clock, and they will last a few years and then they need to be replaced because of the clock skew and so on, and also the battery issue, you cannot remove the battery, so the battery basically becomes empty. Of course, handling them is quite impractical because, I mean, you need to distribute the tokens, so you need to send a physical device, you risk losing it. If you lose it, you need to ask for another one, and it takes time and so on, okay? All these disadvantages include, in addition, may require special server hardware, okay? That, I mean, not all organizations would like to buy. Okay. Software tokens instead are quite convenient from this point of view. Typically, it's an app on a smartphone nowadays. You might know some of these apps, like Google Authenticator, the Microsoft Authenticator. I think most of the big websites have their own application that can generate tokens, like GitHub, I don't know, others. I mean, there will be plenty. Plus, I mean, others that don't want to use a standard, they have their own system. They are typically the banks, okay? Banks want you to install the app because inside the app, in addition to browsing your information and do the operation you can do with your account and so on, they can generate one-time passwords when needed, okay? Maybe automatically, you don't see them. Maybe they give you a code to copy-paste, I mean, to manually copy-paste into the website for login and so on, okay? Some of these mechanisms are standardized. I would say most of the websites, which are not really critical, like not banks and this kind of stuff, or like speed access in Italy, you know, for the digital identity, I mean, use a standard, okay? And you can have a look at the standard. I mean, there is an RFC discussing these issues and also establishing a standard that is very commonly used nowadays, okay? Like Google plus GitHub and many other systems use this standard, okay? There's plenty of them, okay? I should have a look at what's inside my device and the websites, and you see almost, if not all of them, use the same standard, except for the cases I told you, like banks and this kind of system, they want to have much more control on the system, okay? So, example usage, how do you use it? Well, actually, it's up to the server to decide, I mean, the designer of the API, so, and then the server needs to ask for an additional piece of information that is this TOTP. I'm sorry, I didn't introduce the T. T. T, it means time-based one-time password. You can create one-time password in different ways. Okay, one is combining the secret with the time, but there is a slide about this later on. Okay, that's the best way, because I mean time is public information, it's available to anybody, and you can easily synchronize and know the exact time anywhere. Okay, in any application and so on. Okay, so example of this TOTP usage. So the server wants this TOTP code when a sensitive action, including the login, as we will see, is required, okay? And this code changes over time, okay, because it's time-based, we said. It combines a secret and the time with some hash function, as we will see in a few minutes. The advantages of this system is that it's very cheap, okay, no logistic issue, you don't have to distribute hardware and so on, and easily change. In case you lose one, you want to invalidate one and so on, you just mark them as invalid on the server side. I mean, you drop the secret and that's all, and you create a new one. So very convenient as any piece of software, right? And the disadvantages is that as smartphones are not really secure devices, right? They connect to the network in different ways, with different technologies, 3G, 4G, the Bluetooth, and so on. And so you might have installed some insecure software that can try to hack your device and so on, exploit some vulnerabilities, etc. So it's going to steal the secrets, and this becomes a problem, right? And also, the TOTP app might be on the same device used to authenticate, so you can browse the website from your mobile and insert username and password, and then they ask you for the TOTP, and you open the TOTP app and you put the code. I mean, that's not the best possible situation, because it's the same device, so if it gets compromised, I mean, both the password and the second, the token, the TOTP will be stolen, right? Okay, and then there is the issue of how to establish, I mean, the basics that is needed to make the TOTP work. So this common secret, okay? We need to have a common secret that is shared between the client and the server that received the request. This is typically done during the TOTP activation phase. It's like when you register for a new, a new user. They ask you to set a username. Okay, it's free. Go ahead, and then they ask you to set up a password. Okay, so the first time you set up a password, and then next times they will ask you for that password, and you need to remember that password. And the same happens with the secret for the TOTP. Okay. Typically shown as a QR code, as we will do in the next few slides, which is memorized in a device like a smartphone and never sent again by the server, so it's never shown up again because it's secret, right? Only the first time, and you need to keep it, and you need to keep it secret as well, okay? Because if as a server I show it again, I'm not sure I'm showing it to the original user or to some attackers, right? So I want to show it only once at the beginning. It's like when I set the password, I only set once at the beginning. Okay? Okay, good. As usual, there's a lot of discussion about these systems on the OWASP website. You can click and have a look and read with, and take your time to read these discussions. But I mean, we will try to summarize the most important concepts here quickly. Okay? So, TOTP, I mean, initial setup. So in the initial phase, you have the server. Server randomly generate a secret that is then shared with the client, okay, with the TOTP device, typically the smartphone, right? And the shared secret is saved in clear text in the server. Plus, it is shown again in clear text to the user. And the application, I mean, the Google Authenticator, Microsoft Authenticator, and any kind of authenticator, there are also free app, open source apps that can do this action, scans the QR code, and basically the QR code says, I'm the website ABC, and the secret is this long string of random letters, numbers, and so on, okay? So you don't have to type it because it's really inconvenient, right? It's pretty long, because if you want to make it secure, it needs to be pretty long, and typing it would be tiring, and then maybe you copy paste, and a lot of things are simplified if you can scan it and just acquire the secret, okay? So the TOTP device reads the secret. The shared secret is saved in the memory of the application, maybe even in a secure place inside the smartphone. Smartphones nowadays have a sort of security area, security part of the device where you can store information, and the information doesn't leave this area again in the future. Okay, you can only overwrite this part and so on. That's for storing this kind of security information, okay, security-related information. And when you need to use it, how does it work? I mean, the TOTP device needs to generate a code and one-time password, OTP, okay, one-time password. So it takes the device time and the shared secret that has been saved before, and it passes this information to an hash function, which is exactly the same that is used on the server. It gets a TOTP code. The OTP code is shown to the user, and the user insert it and send it to the server with the system, with the modalities that are required by the server. Typing it into a form, that's the typical way, or maybe you need to click on something, and like in a banking application, and this is automatically sent to the server, certain API, and so on, okay? And the server actually does the same. It has a server time, a shared secret, it passes to the hash function, it gets a TOTP code. If it's equal, in the most simple case, it is equal, yes, okay, we can proceed. If it is not, okay, we reject the request, okay? Because like we have, we inserted a wrong password, right? And the point is that here, device time and server time may not be synchronized perfectly, right? Because a clock have a drift over time, like the watches and so on. And so if you don't synchronize the time for quite a long time, like a few days, you will have some misalignment of a few seconds, depending on the precision of the clock, the hardware, and so on. Okay? So servers could be quite easy to synchronize because it's always active. You can ask for the correct time to network servers many times a day and so on. But the device time is quite an issue, right? And so typically the server accepts a set of TOTP codes inside a window of valid codes, okay? A temporal window. It means, let's assume that the device clock is not synchronized to the server clock, and it is late with respect to the server clock. So it generates a TOTP code, which is not actually the one computed by the server, but the one computed by the server if the clock was like 30 seconds before, okay? And the server will accept it, okay? And also if it's in the future, maybe, the clock of the device runs faster than the one of the server, and so it will accept the code even if it's a bit in the future, okay, with respect to what has been generated on the server. So this is called a window for the valid code that are accepted by the server, okay? And this is configurable, okay? So, we will keep it quite small because in our example, basically, client, we don't expect a big drift, but typically, I would say most of the websites use something like 4 or 5 codes in the past and in the future, okay? And the point is that, however, when one code is used, let's say the blue one is used, sorry, the blue one is used, then all their codes becomes invalid, because at this point, I know that, I mean, the client clock, the clock of the TOTP generator is set in a certain way, and so I expect in the near future that it will only increase. Okay, so it cannot go back. If it goes back, it means it's an attacker. So I don't want to accept it. Okay, so just drink a little bit. And so older codes will not be accepted for future actions once a certain code has been used and validated by the server. Okay, so given this caveat, I mean, the system works. And counter is typically derived from time, typically as Unix time divided by 30. You know what is Unix time? Unix time is the number of seconds from 1st of January 1970. Okay, so pretty long time ago. I mean, the number is around, I think, 2 billion, so more or less this number, maybe a little bit less. Okay, 2 billion seconds have passed from that date. And it's something that can be generated easily by any software, okay? Computed easily, okay? Okay, good, so that's a system, okay? In practice, how do we implement it? And then we go to the application and try to implement it. Well, we create a secret in the server, and typically it's a server that creates the secret. So you don't have to send any secret to the server. And also the server generates this QR code that is shown to you, because it's much easier, right? I mean, you could even do the inverse path, but I mean, you require an app and you need to generate something secure and so on. I mean, it becomes much more difficult. And then you need to type it, type the secret for the server and so on. But I mean, you cannot really say to the server, please scan this code that is on my smartphone. Okay, it's a bit more complex, while scanning something that appears on the display or for a web application is much easier. So it's typically, the secret is a vector randomized, often greater than 32 bytes. I mean, you know, the longer the password, the better it is, and the longer the secret, the better it is. And it is often converted in a convenient format for reading and storing. Nowadays, it means always, almost always base 32 format. It basically means you can use all the letters of the alphabet from A to Z, plus a few numbers, okay? And that's why you see these secrets encoded in this way, because then it can be converted into a binary representation, much more compact, and basically base 32, I think it means we are using 32 combinations, so it's 5 bits for each letter you see in this secret string, okay? I mean, this procedure is all standardized. And then you store the corresponding string in the server database. And I mean, storing a string is much easier than storing a binary data, right? That's why we use these strings. And we communicate this string to the user, typically through this QR code and so on. And actually, this is the QR code we will use during our examples, and we will use as well for the exam and so on. And I mean, you can even generate this QR code quite easily, but I mean, this code, this JavaScript code is in gray because, I mean, you already have the QR code here on the slide. You just have to scan it, okay? But just for the future, in case you want to generate a QR code, you know how to do it, okay? It's pretty easy. I mean, I typically use a library, of course, because you don't want to implement all the stuff to generate a QR code. But I mean, the URL that is encoded in this QR code is this OTP out / TOTP and so on, and you can even give a name for your application, so the application scanning the code knows how to call the code and makes you recognize the code among all the other codes which are designed for other applications, okay? But if you scan it with the normal QR code scanners, you will see this URL, okay? If you scan it with an application that handles this TOTP calls, of course, I mean, they don't care to show you the whole string, they just grab the secret and store it. Okay, good. Only for this course, okay? We need to simplify things, because then you need to come at the exam, we need to test all this stuff and make sure it works, and you are like 100 and plus at the first exam call, etc., and we don't want to lose time useless. in a useless way, okay? So only for this course, the second generation part is not required. I mean, we will not require you to generate a new code for a new user and so on, and we typically, we will not ask you to design the part that creates a new user, okay? Just because of convenience, it's much easier, it's simpler to test and so on, okay? So we will have some users that require two-factor authentication, and we ask you to, for this user, to use the same secret key and secret value that has been shown here on the slide. And it will be reported in the exam text as well, okay? Don't worry, and that's a string, that's a secret string, okay? We know it's not secret anymore now, but I mean, we are just debugging right at the exam and making sure that, you implement the things as you are supposed to do, right? Not really, testing the fact that you really generated a random string. You just use a good random function and that's all, right? Okay. Okay, it's the same for everybody. It means everybody of you students, for simplicity and testing speed at the exam. But please do use it as if it was an actual, real secret string to store in your application. So don't store it outside the database. Store it in the database associated for each user. And for each user that needs the two-factor authentication, store the same string. Why do we need to store the same string for each user? Because in practice, they will be different, okay? Just for our convenience at the exam. We don't want to stay here, scan the code, and then the code cannot be read. You have an issue with the implementation of the pure code and so on. All this kind of problems that might happen. And then what are we going to do at the exam? We cannot lose time to debug what's wrong and so on, or typing this, long strings for secrets and so on. It takes 1 minute. By 100 students, it means 2 hours, additional 2 hours to run the exams, right? For what? Nothing, because one secret is the same as another secret for our purposes. Okay, so don't store it in the server code, store it in the database, store a secret for each user, even if it is the same, okay? I'm writing this in bold as well because, last year somebody said, well, actually, it's the same secret for everybody, so I just put it into the server code. Yeah, I know, but it's wrong. It's like you hard-coded a password, the same password for every user, right? It doesn't make sense, right? I know it's the same, but it's the same because so I don't have to scan every time, the QR code and type the string and so on, just for speeding up the things, okay? Okay, so this is just a warning, quite simple, and we will give you an example. You just have to copy-paste the example, nothing really new to invent, okay? How do we store the secret in the server? Well, first of all, the TOTP secret is stored in clear text, okay? It cannot be hashed like we do for the passwords, okay? Because it needs to be used by the server to generate the TOTP code, as it is used by the client, the TOTP application, for generating the code every time it's needed, okay? So the secret is to be stored and managed as any other secret information, okay? You can, again, see secrets management sheet and so on in the OWASP website, okay? Of course, we are simplifying a lot of things. We know, in this course, because we have the exam and we don't want to use like 40 minutes for each students instead of 20-something, doing things which are trivial, right? And so we basically say, all in this course, only for simplicity, just use an additional column in the database table that deals with the users. I would say 100% of the exam submissions will have a table users, because we have users to authenticate in the application, basically in all exam texts, okay? And so typically you have a table user where you store a user ID, email if it's needed, the password, hash the password with the salt, that's what we said last time, plus the secret just in case the user can do the second factor authentication. Of course, if the user is not enabled for the second factor authentication, that column will be empty. That's fine, okay? Don't just don't assume that all users can do the second factor authentication. Maybe second factor authentication is only requested for some actions, like logging in as an admin, for instance, just as an example. In our example here today, we will require the second factor authentication for doing a delete operation on the answers, okay? So if you log it in with the second factor authentication, you can do deletion, otherwise you cannot, okay? Because we say, I mean, deletion, we assume it's a dangerous operation, so we want to make sure that, I mean, the user is actually authenticated in a strong way, okay? So an additional column in the user table for this course or for the exam is okay. It's done with the password, OS, and salt. Maybe in a production system you want to use what is recommended, maybe by your company or by anything else like this, what is it, this cheat sheet and so on. Maybe you want to store it into a credential server and so on, so something much more complex, okay? That gives you more, let's say, a more secure configuration on the server side, okay? But again, we need to keep things a bit simple, otherwise it becomes complex to test, and then maybe you fail the exam just for trivial stuff, right? I mean, we can set up an authentication server somewhere at the Politecnico and ask you to use it and so on, but then maybe, the people not attending the course, the people that have some test it at the last minute, everybody's testing at the last minute, there are issues and so on. So, I mean, why we should care that much about these issues when, I mean, we just want to make sure you got the concept right, So, additional column in the user table for the TOTP secret is fine for the course. Okay, what does the client do for the TOTP? I mean, after the authentication, okay, so authentication means traditional authentication, username plus password. The user is presented a form that asks for TOTP, okay? So you first need to recognize which user is asking for the authentication, and then if you recognize that the user requires second factor authentication, you ask for the second factor authentication, which is more or less what every website does nowadays, okay? You first log in and they decide if they want to ask you for the second factor authentication or not. Often, if you already have a cookie or you logged in, I mean, not too far in the past, they don't ask because they trust you in a certain sense. If you never logged in on a certain device, it means you don't have a cookie that you send together with the authentication, a cookie which is more permanent than the authentication. I mean, they ask you for this second evidence for logging in, okay? So it's up to the website to decide if they want to ask you for the second factor authentication or not, okay? And in our applications, I mean, there will be something written in the specification when we think it's appropriate to ask for the second factor authentication. And the second factor authentication, so this TOTP code, will then have to be validated in the server. So the server has to perform the same computation of the client and check if the code is the same. I mean, the result is the same within that window that we saw before, okay? And just for convenience, we have a React application, right? We store the fact that the user successfully performed the second factor authentication in the application memory, as we did for the authentication in a React state. You remember we had the user object, we had the is logged in flag. We can have a flag again, is logged in TOTP. This is just for convenience. I mean, it's not a matter of security because the security relies on how the APIs are implemented on the server side. So the APIs must check if the authentication has been performed with the TOTP when you want to perform some action that requires the TOTP, okay? And this is up to the server side. But on the client side, as we say, I mean, if you already know that an action shouldn't be allowed by the server, maybe you can disable the action in the user interface, right? I mean, why should I enable the delete button if I already know that without the second factor authentication you cannot do it? I mean, it's just convenience for the user. It's not a matter of security, it's just a matter of convenience, okay? Okay, good. So, normal form, usual form. I mean, we have 3 forms until now in our application, right? The form to add or edit an answer, the form for logging in that we saw last time, with username and password, and here we have a third form, just one field that is the TOTP code, okay? Control the form component, TOTP code, okay, there's on, change, and so on. It's in the code, it's not here. And then when you submit the code, prevent the fault, of course, and then you go to the server and you need to have an API that checks this code, and it will remember that this session has been authenticated with the TOTP code as well. Okay, so it's something to be added to the information on the server side. Okay, and then just for our convenience, we keep this information on the client side as well, as I just told you. Okay. Okay, good. So we are going to send basically a very simple object, JSON object called with this value inserted in the form to the server, and we need to design an API route on the server. Login TOTP, that's a possible name. I mean, that's fine. Nothing special is needed in this sense. Okay, what does the server do? Well, the code is validated on the server, and if everything goes fine, so it means it matches in the time window, the condition is remembered in the session information for later checking in other APIs when it's needed. Okay? Like if you check if there is an active session is logged in on the server side, you can check if there is a flag inside the session that says that you performed the TOTP action, the TOTP validation at login time as well. If it's not, it sends back a generic response saying the code is not correct. It's like when you log in, right? Username and password, incorrect, please retry and so on. Or just, go back and do whatever you want. We will prevent you from doing actions that require authentication and so on. So it's up to the application logic to decide whether the user needs a TOTP and the user can proceed without the TOTP with less functionalities. You can also allow the user to perform other actions, as we will do today in the application. We say, we have actions like upvote, downvote, no authentication required. We have actions like adding an answer, authentication is required, but no TOTP is required. And we have an action delete where authentication is required, as well as TOTP authentication. Okay? So we have all the 3 cases inside the same application. And depending on how the user authenticated, we can decide if the user can do the action or not. Okay? So we need to create on the server side a server endpoint that performs the second factor authentication and store the result in a session. As I told you, this is a possible route. It's fine to use it for the exam as well. You don't really have to invent anything here. Of course, it works only if a session is already established. I cannot log in a user just with the TOTP. Okay? In principle, we can, but it's not second factor authentication, it's just one factor authentication, right? It's probably not as good. Okay, for each server endpoint that requires second factor authentication, every time always check on the server if the user performed the second factor authentication. So it means there is a middleware that we will design that we need to put in the list of middleware to be executed before executing the action required by the user. For instance, in the example, I told you the delete action. Okay? Good. So let's see how to implement the stuff, and then we will go to the code. So how do we use TOTP in Express? Well, there's a module, OTP out. Okay? It's very convenient. Actually a package, an NPM package. What we said about the packages in the beginning of the course still applies here, but unfortunately, we don't have the power and manpower and possibilities of using a private NPM repository and so on. But of course, this kind of library should be secure, right? It should be checked by somebody. They make sure they don't leak information, they do things in a correct way and so on. Okay? But, we just install the package and use functionality from this package. Just a warning for the ones who followed the course, attended the course last year, yeah, only last year, because we introduced this last year. I mean, we changed the things, how the things are implemented a little bit with respect to last year. Okay, last year we were using a less reliable library, a different approach. I mean, it was not really one time and so on, but I mean, this year that's fine. This is required for the exam for this year, okay? Okay, so this OTP out gives us a TOTP object that provides a set of methods, functions, okay? Just to tell, just to make sure that you can compute this value, or you can check the validity of the value that is received by the client, okay? You need to pass, of course, the secret at actually initialization phase with the new TOTP object, and you need to set the parameters to be used for computing the code. These are the very typical parameters that are used nowadays by almost all websites, okay? Pretty secure, I mean, SHA1 as an algorithm, 6 digits, period of 30 seconds, so every 30 seconds the code changes and so on, okay? And I would say, except the ones that want to compute it internally in their app, all the other websites are using these parameters. So we are going to use these parameters as well. Okay, you can change these parameters, maybe make it longer and so on, but I mean, you need to communicate it in the QR code, the application has to support it and so on. So I think sticking with the default parameters is fine, okay? And these previous parameters, again, must be used for the exam, because using the same secret is not enough. We need to agree on the number of digits and the period, etc. Otherwise, you compute a different secret, a different OTP, sorry. The secret is the same, but you compute a different OTP, and of course, it doesn't work. Because on the server, we use these parameters. No, sorry, the server is up to you. I mean, on the client, our client, we are using these parameters, okay? Because we already scanned the QR code, that basically said nothing, and so use the default parameters. Okay, and then you have a validate function that can validate a token. You can decide the length of the window where you accept the codes. And it returns a value. This is important. It's this delta, okay? If it's null, the code is not valid, so it means it cannot be found inside the window, okay? That we specified as a valid window. And, okay. And this delta is used to compute actually the step at which the code has been generated, okay? Because we need to store this step in the database to make sure this code is actually one time. It means that we will not accept codes who will have a step previous to this one and not even this one because it's already been used in the future when we receive new codes. So we will make this code really one time. Okay, can be used only one time. And this value is, in practice, is this one, counter or time step. 119, Y20, Y21, etc. This is more, right? I mean, nowadays it's like probably tens of millions and so on, because, I mean, the Unix time is a billion something, right? So, I mean, it's rather long value, but, I mean, it increments by 1 every time 30 seconds passes. But, I mean, we don't really care. I mean, it's computed automatically by the library. So, I mean, just store it, okay? Current counter plus the delta, that's the actual step, okay? And we need to remember the last used step in the database. So this actual, this last TOTP step has to be stored in the database as well, not shown here in the code. And also, we need to do the check if the token is valid, that the actual step is not less than the last TOTP step used for performing the TOTP authentication, okay? So we are not going back in time, okay? And we are not reusing the same code. It's a one-time code. If an attacker in some ways manages to get this value, and it has, of course, an authenticated session, it cannot create a TOTP authenticated session because the code has already been used. It will not be accepted anymore by the server if it's sent again. Because it says if the actual step it's less, of course, but also equal, okay, to the user last TOTP step. I mean, user is just the object loaded from the database. Last TOTP step If it's already been used, it's invalid. It can be used only once. Okay? Good. If everything is fine, we store it in the session, and we also store it in the database, and we return true. It means we verified the token successfully. Okay? That's important, but I mean, really, I mean, it's important that you understand the mechanism, but I mean, from the practical point of view, you copy-paste this function, and so that's fine. Okay? Oh, that's the explanation, right? So one time, that means here, if it's equal, okay, we don't accept it because we want it not to be used yet, okay? So some caveats. Make sure that when you load the information from the database about the user, since, I mean, in our very simple setup, we are loading all the information from the user, so the hash, the salt, and also the secret. I mean, you don't send back the secret to the user. This is very important, okay? It's a secret, right? So, I mean, it shouldn't be sent to the user. The best way is probably to use a function, okay, so you don't forget to drop it from the information about the user when you do authentication, for instance, and so on. And instead of returning the information about user dot, what was it, last step, right? Was this one, user last TOTP step. Instead of this, you drop it, okay, because you return a new object. And instead you can say, can do TOTP. I mean, does the user have a valid secret? I mean, has the secret been set? If it's valid or not, I mean, we don't know. But has the secret been set? Yes. So the client application can know that it can present the form where you can type the TOTP code. It makes sense because it can be validated. If there is no TOTP secret on the server, it's useless, right? I mean, we cannot do TOTP authentication. And since this is the function, often like in current, to check if the user has been already authenticated or not, so we send the cookie at component mount time, up mount time, as we did last time. And if we are logged in, the server recognizes it, tells us we are logged in, and we change the state of the client application because we have the cookie, valid cookie, and so on. It's good to tell the application also if the TOTP authentication has already been performed on the valid session that is present on the server side. Okay? So is TOTP rec session method equal to TOTP? Okay? That is what we are going to do when we log in with the TOTP. Okay? We are setting this field of session to TOTP, okay, a string that we decided, I mean, that basically reminds us that the user already performed the TOTP, okay? Just don't forget to remove the secret. We will check this, okay? We will have the network tab open always. We will check what comes back from after the authentication, okay? You lose points if you send back the secret, okay? I don't want to say, I mean, we should fail the exam for everybody who does these things, but I mean, you risk being, you risk having a security issue. I mean, for sure you have a security issue on your website if you give back, secret information to anybody who's not supposed to have. Okay, and the check. What about the check? Well, the route, again, copy-pasting, but I mean, let's see how it works, okay? So verify TOTP token, and we get it from the body of the request. It's a post API, so there is a body in the post HTTP method, and we get the code. That's the only thing we care, okay? We pass it to the verify TOTP token, which is the function we saw before. There's the window, checks if it has already been used or not, and so on. If success, good. Rec session method TOTP. We can store information, permanent information in the session as long as the session is valid, okay? So, and the session can be accessed to this through this rec session field in the rec, okay? So it doesn't come from the client. It's something that is set on the server side by passport, expert session, and so on, these packages, okay? They see the cookie, and they retrieve the information about the session, and you have the possibility to store information in the session. In particular, you can set the method, and this TOTP is just a string we decided to use to remember this information. Okay? And then, remember, we need to update last TOTP step in the database to prevent the reuse of the same OTP code again in the future. Okay? So this just goes in the database and it performs an update on the row of the user, updating the last TOTP step. That is that value 120, 121, 122, and so on that we saw in the picture. Okay? If everything goes fine, returns authorized or whatever. I mean, OK still is already fine. Or you can say, 401, whatever, not authenticated. That's a possibility, right? Cannot authenticate with the TOTP. No problem. No problem. You cannot perform the action that are related to TOTP, that requires TOTP. Okay. And then you get this information in React and you store it in the state, as we said. Okay. Okay, that's the stuff I already told you. Okay, just an explanation in words about what I already told you. The API get user info that we already have that runs in a use effect at component mount time when app is mounted, just for our convenience. It can get also the information about the fact that actually the session has already been authenticated with the OTP as well. Okay? Good. Protecting server APIs, that's the last part we need. Okay, we have the server APIs, we have the delete API. We said we want to make sure that delete API only works if the user performed the TOTP authentication. How do we check it on the server side? Well, it's very simple. We have the rec object, right? If rec session method equal TOTP, it means it performed the TOTP authentication correctly. Otherwise, it didn't perform it. So we can simply refuse the request. Okay, send back response JSON not authorized. Okay, it's to be done at the beginning of every callback body in each API that needs a protection, as we did for the other APIs like adding, editing, and so on. Is logged in. Well, we can create is logged in TOTP, which actually does just one operation. This is this check. Okay. So is TOTP actually, we called it, it's a bit shorter. We can create an express middleware, rec res next, as we did with the is logged in. Just does one check. If rec session method TOTP, return next. Otherwise, 401 missing TOTP. Okay? So you don't have to copy paste this code in all the APIs that require the TOTP, as with the is logged in, right? So very simple. This is the one for the lecture on Monday about authentication, and this one for today. Okay? Just put all the middleware that you need before your callback that actually handles the request. And if these ones called the res something, basically they send back a response and the rest is not processed because you don't call next. That's how the middleware in Express work. Okay. So recommendation, this is last slide, yes, and then we can code a little bit. Recommendation, authentication and authorizations are complex problems. Never invent your own mechanism, use standardized, well-tested mechanism, okay? Even when you finish your course of study here in cybersecurity, probably, you will not immediately start designing new authentication, authorization systems and so on. It's a complex process. You typically do it together with other experts in the field, maybe when you are a bit more senior in this field. And it takes a lot of time to think about possible attacks, possible weaknesses of the systems and so on. So at this level, please don't try to do anything by yourself, okay? Or invent anything which is different from what is recommended in a reputable website like OWASP and so on, okay? Because, the probability that you get it wrong is really, really, really high. And if you get it wrong, it means that your site at a certain point, if it's interesting for anybody, for somebody, of course, will be hacked, okay? Cracked, call it as you like, okay? So only use standardized, well-tested mechanism. And here we also provide you a way of using this TOTP, which is pretty standard nowadays, as you know, and it gives you a lot of additional security compared to the traditional credentials, username plus password. Okay, so let's go to the code and try to implement something. Let's see what we can do before the break. So as usual, I already made some code available. Okay, so here in the schedule, example, right? Example, it just takes you to the week 11, React QA login OTP. That is basically what we did on Monday. So there is the login implemented, but not yet the TOTP, right? So, okay, good. So let's try what's available. I think I already installed everything. I'm in the correct folder, not like on Monday. Okay, so and node mon index MJS, and the client as node module, so npm run dev. Okay, oops, let's open the browser. Okay, good. So we didn't log in yet. We have no active session at the moment, no authenticated session. You know that because, well, I didn't open it before loading the application. So let's see. You see the request, API session current unauthorized. No problem. I mean, we don't have any valid cookie that defines a session, active session. You see it here, but, I mean, we don't care about these red lines. I mean, we say that Firefox always print them. So we cannot do anything. I mean, if we want to check if we are authenticated or not, there's no other way. The cookie cannot be checked by JavaScript. Remember, it's HTTP only. Okay? Okay, good. So we can log in. Let's see the tab of the network. We can log in. We send username and password. Of course, post API session with the request, password, array, etc. The response is the JSON object of the user, just for convenience. Okay? I already added these two fields because I already implemented the server side, which is the most boring part. Okay? And now we are going to see it. Okay? And you see the response, just to rehearse things. That's the response headers, and you see the set cookie. Okay, now we get a cookie, and the cookie is the one that says we are logged in, because it corresponds to a valid session on the server side. It's HTTP only, and path slash and file, and so on. Okay, just to show you that what I told you before is true. I mean, we wanted to implement the TOTP just for some actions. I mean, some actions have no need for authentication, okay? No, for, hopefully. Why didn't get it? I guess there's something wrong in the refresh, right? So I published some code that doesn't really... no, sorry, it immediately updates. That's the optimistic update, okay? And then it's refreshed, and the yellow goes away. Okay, I didn't see it updated immediately, so it's correct. So we can do add an answer, right? Okay, that's a new answer, Harry. Okay, we could write Harry before the confirmation from the server. I mean, just one field in one place. We can do it later if needed. But I mean, I told you, we want the delete operation to work only if we perform the TOTP authentication. Okay, let's clean up stuff and try. Okay, delete is response unauthorized, missing TOTP authentication, because I already implemented TOTP authentication on the server side, but not on the client side yet. Okay, so let's have a look at the server. So that's the code on the server. Let's make sure it's the correct folder. Yes. So import TOTP, right? Nothing different from what we said on the slides. Passport and so on and so on. You see the verify TOTP token. That's the same function that we saw on the slides. Okay? Just a little bit more comments, I mean, just for convenience, because I don't have so much space, so much room on the slides. So delta tells us how many steps away the provided token is compared to the current one, according to the server time. Okay? Before actual step is current counter plus delta, that's what we saw in the slides. If you want, you can, I mean, this is just for debugging. Of course, not the best security practice, but if you really want to understand what's going on, put some console log somewhere, and you can track values and you can see values and so on. Okay? Good. And reject, replay, or older steps. Older is less than, and the same, that means a reply attack is the equal. We already used the token. We cannot accept it anymore. Otherwise, we update the last user step, and in addition, who will call the verify TOTP token will store it. We store the value of the step in the database as well. Okay? So we will have it. The verify. Where is the verify? The verify, I think it's at the end here. This post API login TOTP, again, the code that you saw on the slides, right? Okay, if there is no secret in the database, it means the user cannot perform TOTP authentication, so the story is already finished. I mean, we answer cannot authenticate with TOTP. I mean, actually, we don't say anything in addition, okay? For security reasons, you should never say, this user is not TOTP enabled. That's not a good thing to say, okay? Okay. Well, no, actually, yeah, this is just a console log. That's for us, okay? On the server, the attacker has no access to the console on the server, okay? I mean, you should be careful of what you log in the server, but I mean, this is just for debugging. Verify TOTP token, okay. If success, rect session method TOTP, so we store the information of the successful TOTP in the session, plus we go in the database and we update the last TOTP step. We need the rec user ID, okay, and the last TOTP step. And let's have a look. Just an update. Update user set last TOTP equal to where ID equal to. Okay, nothing really special, right? Let's have a look at the database. Okay, so that's the user table, and you see ID. That's good practice, I would say, for all databases having a key which is independent of our data. But I mean, email could be the primary key as well. I mean, not really fundamental in this course. Okay, it's not a database course. Name, salt, hash, that's the hash of the password, and we need to be able to see. No, we need to add it, I think. Yes, we need to add a secret. How do we? Why should we? No. Let me make sure. It's no secret. Well, it doesn't matter. We'll create it. Okay. So we have a secret and last TOTP step. I guess I copied the wrong DB file. Anyway, we'll check during the break maybe. So email, name, salt, hash for the password, secret, okay, and last TOTP step. So what's the secret? The secret is the one I showed you on the slide. Why? Just for convenience, so I don't have to create a QR code scan another time and so on. So basically I have my Google Authenticator, I mean with this value that changes over time, okay? I think there is a way to show you this TOTP secret. I mean, we are just debugging, so we are not caring about the secrecy of the secret. So we paste it around without thinking too much, okay? But of course, you shouldn't do it with the real secrets, right? So show TOTP, no, compute compute TOTP from secret. I think there should be, I think this website is, I mean, we paste our secret, and that's the OTP value, okay? I mean, the algorithm to compute it, it's actually standardized, okay? As long as we say 6, number of digits, token period 30, here it's not written, but also algorithm is SHA1, okay? That's the initialization we did in the code, okay? And I can show you, I guess we can show you, I mean, the guys in the recordings, but I mean, if you try to scan that QR code and have a look at what's the number that is computed, is actually the same, right? I can read 524384 here as well as here, okay? So anybody who has the secret and the time can compute the code, okay? I mean, this is, of course, just for convenience, because I had to show you something on the slide, right? But, of course, that's not the best thing to take a secret and paste it somewhere in the random website on the internet, okay? Even though I think this is computed on the client side, so we're not sending a secret to anybody, but you're never sure, right? Okay, so that's a secret. And you see that somebody has empty secret, simply because we decided this way. I mean, I wanted to show you a general example. Of course, in this specific example, probably we want all the users to be able to delete their own answers, right? So probably we should put a secret to, I mean, in the rows corresponding to all users. So all users should have the same secret. Not the same, the secret activated, okay, written. And oh, by the way, we didn't see it last time, but since we are here, you see the hash and the salt. I mean, the salt is just something I typed randomly, okay, when I created the database here. And all the users have the same password, which is PWD. How do I know? Well, I cannot know from the hash. I know because I created the hash, okay? And I've written it in the README. If you don't write this information in the README for your submission for the exam, you have no way of knowing the password, okay? Luckily, you are there and you can tell me the password is 1234, I don't know. But if you don't know the password, we cannot recover it from the hash, okay? So it's really important that you let us know the password of your users. And please don't use too complex passwords, again, just for the exam, because we have to type them, okay? It takes much more time to type complex passwords, switching back from readmes to the application and vice versa and so on, okay? Of course, that's not a good password, right? Easy to guess password and so on. I mean, but again, just for testing, just to speeding up the time it takes at the exam. But the point is that you see that the password, same password leads to different hashes, because the salt is different, okay? So if you have a unique salt, a long enough salt, I mean, this value will be different. Even though, you see, the password is quite, it's actually the same. It's quite weak as well, you know? So, I mean, it doesn't really matter if it's weak or not, but in practice, in real applications, if you see, you know, same hashes, it means typically the password is weak, if you don't have salt, okay? Because, you know, many users tend to use weak passwords. Okay, so this is the SQL needed to create a database. Not really sure why I didn't create it yet, and so we don't have questions. This is an internal table of SQLi3, and of course I can go and copy paste right here. I think we have the secret, that's the correct file. But you see also the last TOTP value, okay? It can be 0 if the user never logged in, so everything is allowed, okay? But I mean, typically when you establish the TOTP secret, the website asks you to insert one TOTP code. Okay, just to make sure you copied everything correctly, it is generated correctly in your application and so on, because otherwise you are locked out from the login process, right? Because if the TOTP is required for logging in and you didn't set up the application correctly, you just locked out yourself from the system, right? So this value can be set when the new secret is established, because they ask you to type the code to make sure everything works, okay? And before the break, let me just show you how to create a new database, because you will have to create a new database for the application at the exam, okay? I think I already showed you in the third week when we talked about the database and so on. How do you create it? I mean, my recommendation is take this SQL that includes all the instructions to create tables and so on, and I mean, I'm giving this to you as well, right? It's in the files that I published. It's a text file. You can type whatever you want. You want to add another field here? Just add it, okay? Foreign key or whatever, okay. ChatGPT, no, what is this? Copilot even suggests SQL, right? Okay, and then what are you going to do with this file? Well, you just use in the SQLite browser. Okay, if you have any problems about this, I mean, we are here in the lab, not next week, but the week after, we can help you with anything, okay? So, new database, let's put it here, QA.db, okay? Yes, it doesn't matter. Okay, and then you execute some SQL, and you copy-paste the SQL. If it works, good. If it doesn't work, you start again, you fix the SQL, and you run it again. Okay? So you create the tables, and you create the content inside the tables. Okay? I'm not, no, I can zoom in, but I mean, it's actually the same code, right? You just run it. So execute the queries. No, I didn't click it. Okay, there's a typo. Sorry. Questions, where is the typo? The comma here. Okay, so run it. Okay, execution finished without errors. Good. Just remember to save the database. Write changes. Okay. Close. It's project file. We don't care about the project file because, I mean, we just care about the database. We copy. We overwrite the database, right? So, yes, so the comma was saved. And so let me close these files, stop the server. I think it was in the home, so QADB here, overwrite. Let's make sure it works. Users, here it is, okay? We just created a new database, pretty easy. I mean, this DB browser for SQLite is available for any platform, Windows, Linux, Mac, and so on. Pretty easy program to use. I mean, but we are just using two functions, okay? Just running an SQL query, some SQL queries, and save the file, okay? And of course, you want to copy it on QADB, QA initial. So in case we want to restore the database, we have the original copy. Okay? And then we need to implement the client part, right? So because now, as we saw, I mean, actions from the client need to have the TOTP enabled, right? So you see, missing TOTP authentication. That's the message coming from where? From the server here. Missing TOTP authentication. That's for the route, the delete route. Is TOTP, and we will break we stop for the break. Okay? Is TOTP? That's a middleware, and let's see. Implementation, yes. Just return missing TOTP authentication. I don't know if you already performed the TOTP authentication or not. I mean, I can see there is a session established without the method TOTP. I see, missing TOTP authentication. I don't care. That's the answer as before. I mean, there is no session, not authenticated. That's all. Okay? I don't care about the rest. So, given the time, I would say we have the usual 10 minutes break. I mean, hopefully not too long. And if you have any questions or comments, just feel free to come to me or just ask now, even if you are not from the course, as happened last week, right? And but it doesn't matter. I mean, we are here to explain to anybody. And no questions, I guess, so we can have the break. And in the second part, we will finish the example and we will finish the discussion about the authentication. And in general, there are general considerations, okay, about this important topic. Okay, thank you. So see you in a few minutes.